Good morning, ladies. Today we're going to continue with the lesson 7 that talks about absolute value functions and graphs. Okay, let's start with the first idea we're having today, the general form of the absolute value function. Okay, so yesterday we took like what's the apparent function was of the absolute value was y. Okay, this is supposed to be a y equals the absolute value of x. So this is the parent function. But here we're talking about the general form of the absolute value, which is y equals a, which is the coefficient or the number of compression or stretching, x minus h. H is the translation with the horizontal on the horizontal translation, plus k. K is the vertical translation. So the stretch or compression factor a is a. The vertex is located as hk. So h and k, they're the coordinate of the vertex, and the axis of the symmetry in the line of x equals h. This is x equals h. Okay. So let's start with the examples we have for today. Okay, identifying transformations. Okay, so compare y equals 3 absolute value x minus 2 plus 4 with the parent function without graphing. What are the vertex axes of the symmetry and transformation of the parent function? Okay, so we have to compare this equation with the general form of the absolute value we have here. Okay, let's solve it together. Okay. Now here we're going to compare this into y equals a x minus h plus k plus k without graphing. Okay, what are the vertex? First of all, what are the vertex, or what is the vertex actually here? So number one, the vertex is going to be hk, right? So it's going to be here, we're going to locate what is h and what is k. H is 2 and k is 4. So now we got the vertex. Here's for number one. Now number two, what is the axis of symmetry? So x, we said x equals h, right? So h here equals 2. So this is the second thing they want. And the third thing, the transformation of the parent function. Okay, now remember the parent function, we said y equals absolute value of x. What are the transformation based on this equation? So first of all, we have to say we had, instead of a here, we had 3. So we had a stretching vertically. So based on this equation, the parent function is stretched 3 vertically. So stretching, let's say stretching. Okay, I'm gonna point them as A, B, C. So A, we have vertical stretch, what's wrong with it? Okay, خلاص. ST, like vertical stretch with a factor of, or with a number of 3, with a factor of 3. B is going to be as, here we have -2, or actually 2 because negative is already here, so it's going to be 2 units. There's a translation, 2 units to the left. No, 2 units to the right, because here it's going to be like as negative, so it's going to be to the right. And the last thing we have here is 4 units upwards. Okay, so first of all we found what's the vertex, and then we found the axis of symmetry, which is x, and then they asked for the transformation. We said 3 is going to be vertically stretching with a factor of 3, and here -2 is going to be like 2 units to the right, and 4 units upwards. That's it for this question. Let's check our answers. Okay, so first of all, we found that the vertex is 2, 4, that's right. The axis of symmetry is x equals 2, we found this, that's right. This function is translated 2 units to the right vertically stretched by the factor of 3, as we said, and translated 4 units up. That's right. We got everything correct. You can use graphing calculator to check it if you want. Like, you're going to plug in this equation in the graphic calculator, they're going to find the answer for you. It's just for checking. Okay, so let's go for the second problem we have here. What are the vertex, axis of symmetry, and transformation of the function? Okay, so they're asking for these things as the previous example. Let's solve it. Okay, so here it's going to be, we're going to find one by one. The vertex will be hk. So h here is 1 and k is -3. This is the vertex. Number 2, they're asking for the axis of symmetry, which is x. X equals 1, as if we're doing like x minus 1 equals 0, so x equals 1, as if we're doing this. Okay, oops. Okay, let me just write them again then. We said the vertex here, the vertex is 1, -3, and the axis of symmetry x equals 1. Number 3, they're asking for the transformation that we have. So we're going to have here a, b, c. A, we have 2, which is greater than 1, so it's vertically stretching vertically with a factor of 2. B, it's moving 1 unit, or translating 1 unit to the right, because it's a negative, so it's going to be to the right. And C is moving 3 units negative, so it's going to be downward. So this is the answer for this question. Let's check our answers together. So again, A equals -2. A is the compression factor here. H equals 1, K equals -3. So the vertex is going to be 1, -3. The axis of symmetry x equals 1, as we said. The parent function is translated 1 unit to the right. That's what we got. Vertically stretched by a factor of 2. Stretched. Then reflected over the x-axis and translated down. Wait, why is it reflected here? Let me check. Oh yes, in the book it's going to be here. In the book here it's negative, so that's why here they solved it with -2, because here A is positive, and if it's -2 it means it's reflected, so it's reflected on the x-axis. It means that the f of x, all of it, is negative. Like it's going to be negative f of x. It's going to be as negative f of x, so -2 f of x, which is x minus 1, all of it. So it's going to be reflected on the x-axis. Here it's not written, so that's why we did not solve it this way. Okay, reflected over the x-axis and translated down 3 units. That's right. Okay, let's go for the second idea we have here of writing an absolute value function. If they gave you a graph, and based on this graph we have to write the absolute value function. So let's solve it now together. So they gave us this graph and we have to write it in the general form, which is y equals a, a absolute value x minus h plus k. So we have to find a, h, and k. So h and k, we said they are the vertex, they're the coordinates of the vertex of the graph that we have here. So here we're going to find it by like -1, 4. This is the vertex. So h is equal to -1 and k is equal to 4. Now what's left for us to find? A. How are we going to find A? A here it's going to be as y equals mx plus b. Do you remember this? So A will be equal to the slope of this graph, but to the left. Like we're going to find a point over here, and we're going to find the slope based on this point and this point. So let's find the a point here, which is 2, 3. Here we're having 2, 3, 2, 3. Again, so for finding A, you're going to find a slope between 2 points. The point is going to be to the left of the vertex. Okay, this is a rule here when you find A. Okay, so let's find the slope here. It's going to be y2 minus y1. So let's find it as 4 minus 3. 4 minus 3 over -1, -2. 4 minus 3 equals 1, and -1, -2 is -3. So A is going to be equal to -1 over 3. Now, after finding these values, the values of these coefficients, let's say, we're going to just plug them into the equation. So it's going to be y equal A, which is -1 over 3, x minus h, which is -1, so it's going to be +1. K is 4, so it's going to be +4. This will be the answer for this question. Let's check our answers. Okay, so here first of all we're going to identify the vertex first. H equals -1 and K equals 4, yes. Then identify the stretch or compression factor here, which is -1 over 3. We found it by finding the slope between 2 points, this point, and the second point will be to the right of the vertex. So we chose a point here which is 2, 3. We chose this point 2, 3. Then we found the slope, which is -1 over 3. That's correct. Then we're going to substitute this into the equation. Y equals -1 over 3, x plus 1 inside the absolute value, then plus 4. That's correct. That was our answer. So this is how to find the equation from a graph. Okay, so let's go to the last example we have. What is the equation of the absolute value based on this graph? Let's solve it together. Okay, so now from this graph we have to know the values. Okay, just let me write the equation first here, which is y equals A absolute value x minus h plus k. So we can easily know the vertex here from the graph, which is 2, -1. So the vertex is going to be as 2, -1. It means we found h as 2 and k as -1. The second thing we have to know here is the factor of compression or stretching here, which is A based on the slope. So we have here the vertex. The first point we have is 2, -1. We're going to find a point to the right of the vertex. So let's have, for example, here we're having this, right? So it's going to be 6, 0. 6, 0. So let's find the slope. It's going to be as 0 minus -1, which is +1, over 6 minus 2, 6 minus 2, which is 1 over 4. So A equals 1 over 4. That's right. So now we just have to plug in the values here. It's going to be y equals A is 1 over 4, x minus h, which is -2, plus k. Here it's going to be -1. So this will be my final answer. Let's check our answer. So first of all, they got the vertex 2, 1, so h2, this step we got it right. The slope is going to be 1 over 4, so a 1 over 4, that's correct. We're just going to plug in here 1 over 4, x minus 2 minus 1. This will be the final answer. It's correct as we got. So that's it for today, girls. I hope you understood the lesson very well. If you have any questions, please ask me during the lesson, okay? Or I mean during the class time, okay? And have a nice weekend.